Hi, everybody. How's it going? So my name is Mike Withrow. I'm a product manager on the AKS team. If you don't know me, I pretty much cover all the security stuff for AKS. So today I'm going to talk about essentially how you can use AKS to meet your application privacy and confidentiality requirements. So privacy, in particular, data privacy, continues to be top of mind for customers, right? So moreover, as we continue to expand the privacy laws and requirements around the world, protect against, evolving malicious action and prevention to a more rights-based approach. This brings a lot of challenges to customers. So essentially, how can you use AKS to cover that is essentially the key thing we're going to talk about today. So taking it from a customer perspective, we'll take Contoso, as everybody's probably heard that term. What are my typical challenges that I got to be concerned with, okay? So at the end of the day, hey, look, I've got a subset of applications that I've got sitting on-prem. I want to bring them to the cloud, but I've got all these confidentiality, I've got these compliance requirements that I'm concerned about. Essentially, how can I deploy them on AKS and maintain my compliance structure? So essentially, we're going to go through today, kind of talk you through how can you, deploy an AKS, how can you deploy an application on AKS, and as an example, maintain maybe my GDPR-based requirements. So we could use CIS or whatever it is, but today we'll just kind of talk about maybe GDPR. So the goal is essentially walk through a set of actionable items and toolboxes, so techniques, and then what capabilities you can use on AKS in order to achieve that structure. So when we look at questions, what data privacy options exist on AKS? How do I know which options I need? Obviously, security is very complex. So which tools can I bring together to provide that compliance-based structure? So just kind of laying out the framework, we'll take GDPR. And we're not going to take all the GDPR, it's pretty complex, but let's take 4 big best practices-based items we'll kind of talk through. So obviously starting out with container image scanning, that's kind of a big one. Audit logging, how do I provide audit logging? How do I manage container data? And then RBAC tooling, those kind of things like that. So looking at container image scanning first, for us, kind of starts out, from a bolt-on perspective, everybody's probably aware of Microsoft Defender for Cloud, right? So obviously, that's the end-to-end solution that exists within Azure from a native perspective. The idea is that DevOps security management, cloud security posture management, cloud workload protection, and that works across the environment. So think of a single pane of glass. So I've got a multi-cloud, I've got a hybrid cloud topology. I can bolt that on top of my AKS cluster. Within that, there's obviously a container security-based initiative. So the idea is providing security posture management, vulnerability management, which ties in that image scanning that I was kind of talking about. Now, with our key capabilities I'll be talking about here as well, this is really end-to-end. So from build to registry, all the way through runtime as well. Advanced threat protection, and deployment and monitoring as you're kind of building through. So new today as well, we'll talk about essentially security graph to analyze your blast radius. So as you kind of look through, there's obviously concepts of looking through your vulnerability or compliance, but how do I know, hey, look, I've got a 3-tiered application that I've deployed in a container. I've got a database, I've got a storage account, I've got a load balancer, everything's interfacing with. How do I know the risk that I might have deployed? So you can see here the relationship between, hey, look, I've got my pod in a cluster, I've got it out, I can see the entire topology, the entire blast radius that exists, and then bringing in that vulnerability data as well and the compliance. Because depending on, is it network exposed, is it network restricted, the blast radius will change. So taking all those components into account, we'll start to go and show you as you're deploying your infrastructure and you're dynamically deploying your applications, your risk will change and your risk will evolve. And as you're connecting your applications, changing from your blue-green, from dev test over to prod, that will evolve as well. And so this will dynamically show you that state as you're going through. As well as that, there's a new agentless-based capability that we're announcing as well. And so now, from an agentless perspective, so if you think of your footprint, now agentlessly, it'll be giving you insight into your vulnerability state, provide vulnerability assessments, attack path analysis. So like I said, as you're dynamically deploying your applications, it'll dynamically evolve for that, and then graph-based queries will be tied in there as well. essentially, this all leads into a hybrid-based approach. And so as everybody probably remember before, we have a single SKU for Microsoft Defender for containers, which is essentially a runtime-based component. So there's a daemon set that runs on your cluster. So now, and that's essentially the agent-based topology. So think of that as really like the runtime-based components I'll talk about here in a second. But now with the agentless, essentially gives you two different topologies you can kind of leverage. Obviously, diving into the vulnerability is the big piece here as we go through. So now, as you look at it from a plan perspective, obviously before you deploy the Microsoft Defender for containers, and that was essentially vulnerability assessment through runtime as a singular SKU. Now that's been forked out, and the idea is that if you just want vulnerability assessment, you could use posture management, all coming through agentless, so no footprint on your cluster at all coming through the API server to give you your vulnerability state. And that's obviously the full lifecycle as well. And then if you are worried about runtime, you're looking now, you're dropping components down in the cluster through that daemon set. You can deploy the Defender for Containers SKU and get the full lifecycle management as well. So it's no longer a single SKU. It's actually been forked out to give you some more options. And so when you look at posture assessments, that's obviously giving you a secure score, your control plane recommendations, and your data plane-based recommendations as well. And then on the vulnerability management side, obviously zero configuration, right? And that's the key thing. So you're not even deploying an agent on your cluster. Essentially, it's all going through agentless, so zero configuration. You just deploy your cluster, and then boom, you're starting to get your state. So obviously, runtime comes in that. So continuous scanning of runtime, visibility with ACR. And then you see build there. So we were trying to get this in for this conference as well, but that's coming a little bit later as well. So the idea is that as you're shipping your containers, whether you're building through GitHub Actions, you're building through ADO, obviously that static analysis will be happening. And then as you move that to the registry, that will be lit up as well, and all the tooling's lined up as well. So if you played with it before, there was a difference of tooling, but now we've lined that tooling up. That's the reason we had a little bit of a delay. But now, as I'm moving through the pipeline, essentially from build to registry to cluster, you'll get that vulnerability assessment state right through the SKU. All right, so looking at auditing as kind of the next big piece, right? So George kind of alluded to this as well, so I won't spend too much time going into this, but essentially for us, that's all about Azure Monitor for containers, right? So the key thing is that it gives you the ability to observe live logs, there we go, and Kubernetes event logs for the container, obviously through pipelines, all the way through the Azure Kubernetes service itself. And then the key is that with Azure Monitor, right, now you bring in all the different capabilities, right? You see, so Prometheus in there, visibility, insights into your topology, and base response. And so with the Prometheus integration, obviously you're getting in, obviously your node, your pod topology is all going to be there. It's going to be tied into the log analytics agent, all through Azure Monitor. You're going to get dashboards, the analytics itself, and the alerts. The big value add, as you kind of go through, is now you're getting deep insights into the workloads itself. So obviously logging on Kubernetes is really hard. There's a lot of data there, right? So essentially with Azure Monitor, now you've got a single place which kind of brings all those logs together. So you're seeing from the platform itself, the topology, obviously the container runtime, the orchestrator itself, any problems in Kubernetes, and then obviously the workload on top. You can all see that end to end directly through the Azure Monitor for containers SKU. All right. So managing customer data is a big one as well. So there's a couple of different things that I'll talk about here in the managing customer data. So workload identity is one feature set. So as you're going through, encryption is a big part of GDPR. And then confidentiality. Two specific components I'll talk about as we're going forward. But obviously, Azure AD Workload Identity is the solution so you don't have to deploy, use connection strings or passwords in your Docker files, as an example. So it gives you a secure way for your applications to interface with Azure-based resources. That's been the construct. So everybody's probably aware of pod identity, which is a long-standing, it's actually the longest-standing public preview feature set on AKS that allows you to securely connect those applications. That was essentially based off of IMDS. We have since started the deprecation of that product now over for workload identity, which is OIDC based. I'll talk about that a little bit more as well. But the idea is that now through service account token volume projection and OIDC federation capabilities, you can now essentially OIDC base enable your applications is the key thing. And so now you're no longer using the node identity down on the node. You're using a token that's referenced from AAD. So it's a much more secure, more streamlined based solution. The key thing is that finally, we have a solution in this space. So Azure AD is finally GA'd. So I know a lot of people are waiting for this, but yeah, so if you look, as long as you're using the latest CLI 2.47, it is essentially out, but the documentation is actually deploying as we talk through this here. So it's in all the public regions. If you're looking at sovereign clouds, it'll be out by tomorrow most likely, but this announcement's pretty early, so I was actually working through this as I was getting ready for this presentation. The big thing to understand, so if you're using pod identity today, what does that mean? Okay, so don't think because this is GA that you're orphaned out. So the open source solution has actually started the deprecation process. But we on the AKS side, through the pod identity managed add-on, will provide extended support to give customers time to migrate from the preview version of pod identity over to the GA version of workload identity. So all that's in our documentation as well. So with that as well, we also understand that, so as an example, who in here is using pod identity today? Has anybody started to migrate from pod identity over to workload identity? Okay, so it's pretty streamlined. There's some fundamental differences, some key things that I'll kind of talk through. But as you look at pod identity, think of that as really based off of IMDS. So it's really using the node identity that sits down on the environment, right? And so now when you look at workload identity, it is very SDK based. So there's a difference in essentially how it works. The key when you look at migration is really around that SDK support. I've put that in all the documentation. But as long as you're using Azure Identity, your application will work. If you're using MSOL, as long as you're using the right version of MSOL, your application will also work. Now, if your application is running ADOL, now we have some things to kind of talk through, right? But the gist of it is that if you have pod identity today on your cluster, you can deploy workload identity in parallel on that cluster as well. So now what you would do is essentially while that pod identity is running, you would configure workload identity as it would be a greenfield, even though it's brownfield. Then you would simply redeploy your application. So as long as that application on that redeploy has the right SDK, it will essentially just work. There's nothing for you to do from a customer perspective. If it doesn't work, that means you're essentially there's an issue with your SDK. So you have two paths for remediation there. So one, you can obviously update your SDK to the supported SDK list. What the SDK team is saying, as long as you're running Azure Identity, it will just work. That's the key thing there. But if it doesn't, we do have a sidecar that you can run, which is essentially just proxying off the IMDS calls over to OIDC. That we had as part of our preview feature set, but now that we're GA, we obviously don't want to support that. But you can run it in a short type of window. So think of it as an example, you want to give yourself an extra 2 months to migrate over as an example. That's essentially where you can use the sidecar. But don't think of it as a long-running process to run that sidecar, which essentially proxy off your IMDS calls over to the OIDC endpoint. But essentially, as long as your application is there, once you've got your SDK running, because of the way we configured workload identity, there's a webhook that runs. So on that redeploy, it'll pass in the client ID for the service account token so that that application within the namespace construct can go now and talk out to the Azure service. The other interesting part about this as well is you look at federated identity. I don't know if everybody's aware, but before, with pod identity, it was based off of service principals and managed identity. Well, service principals had its issues, and so we basically built a wrapper around managed identity. With workload identity, we actually built federated identity. So the key with federated identity, it's another adaptation off of managed identity, and it is not bound by the tenant. So that is a real interesting part. So you could technically build an AKS cluster and talk to an S3 bucket, talk to Google resources on-prem. Doesn't matter, because now you can share. There is no longer bound by the tenant. All right, so hopefully everybody can see this. But this is essentially a there we go. All right, so hopefully this is a pretty simple demo, which should run. All right, I'll talk through it. Probably can't see it anyway, but from a command line perspective, the implementation is pretty simple. Like I said, it doesn't really matter if you're greenfield or brownfield. The idea is that you're essentially enabling two capabilities on the cluster. OIDC issuer and the workload identity webhook that I was kind of talking about. Now that we're GA, we're actually going to be integrating OIDC issuer by default as well. So you'll see that if you look at our AKS announcements here in the next couple of months, we're going to be turning that on by default. We'll probably get down to the path of turning on workload identity by default as well. We just need everybody to turn it on. But OIDC issuer will be on there by default, so all you'll do is enable workload identity. Essentially, once you've enabled workload identity, the next thing you do is build a federated identity. So it's the same construct that you run from a CLI perspective, just like you build a managed identity. Essentially, think of managed identity as IMDS-based, whereas federated identity is OIDC-based. So you build out your identity, then all you do is associate your identity with a service account within a namespace. So think of that, your lines of separation that exist there. Once you've integrated that service account, now you go and tell AD that, hey, look, this configuration is trusted. So here's the issuer URL from my cluster, here's the namespace with the service account and the client ID that's associated with that, and now AD says that's trusted. So now when I deploy an application in there, it essentially says, hey, look, this configuration is trusted. As long as I'm trying to reference the application, now it'll go through and talk to the database or storage account or whatever it might be. Like I said, when you look at it from a migration perspective, from pod identity, as long as you have that client ID in there, that federated ID, it essentially will just work. All right. So moving on from that, the next part is kind of getting into encryption. Encryption is kind of a big set. So right now, what exists in AKS today? Most people that are using AKS, they probably already know this. But essentially, there's two big feature sets that we have, right? It's around data at rest and data in transit. So really, what is that? What are we looking at? So obviously, Azure Disk Encryption, host-based encryption, TLS, and then KMS. So depending on how you manage your secrets, there's really two options that exist within AKS. If you're putting your secrets in etcd, that by default is not encrypted. We do allow you to encrypt that with KMS. Or we have CSI Secret Store, which you externalize that secret in an external vault. But essentially, those are essentially from top to bottom the options that we have today. On top of that, I know a lot of people have been waiting for this one as well. So now we have BYOK for ephemeral OS preview is finally out as well. So that's one of the other final pieces we needed. So now you deploy an AKS node with ephemeral disk. Now you can go through and encrypt that as well with your own keys. Managed disk encryption, as kind of talked about, gives you all the different storage accounts, and then KMS itself, if you're leveraging that for your cluster. So looking at managed disk encryption, it gives you two key feature sets. So obviously Azure Disk Encryption itself, and then server-side encryption. So this obviously works against, it's obviously guest OS-based encryption, but it works across your Linux workloads and your Windows-based workloads. So obviously if you're Windows, your BitLocker, and your DS Crypt if you're on the Linux side. And then on the server side, encrypts in XStore as an example. And the key thing is by default, all managed blobs have server-side encryption with PMK support enabled. And all this works with BYOK as well. So looking at BYOK ephemeral, so essentially if you look at the typical flow, an admin creates the user, creates the disk encryption set, resourced by specifying integration with Key Vault, and grants Key Vault access through an Azure Active Directory identity. A VM user encrypts the disks by associating them to the disk encryption set resources. And then the disks use the Azure identity of disk encryption set to authenticate with Azure AD to access Key Vault. And then the disk gets wrapped key, unwrapped key requests to Azure Key Vault for encryption as well. On the KMS side, because it is leveraging Key Vault, depending on how you've configured your Key Vault, it essentially just works. Hopefully everybody's doing private Key Vault. That will work as well, but if you're doing public as well. So when you deploy KMS, you already have your cluster set up. Depending on whether you deployed it with, like I said, public Key Vault or private, it's just a configuration switch to a pass, and then we do all the work under the hood to make sure that the communication path is there. With that, now I want to kind of fork over, talk about the confidential suite on AKS. There's a lot of work we've been doing for the past couple of years that we're finally starting to bring home of introducing a full top-to-bottom confidential suite on AKS. There we go. So when we look at confidentiality, it's really a set of guiding principles of zero trust, right? So verify explicitly, use privileged access, and assume breach at all times. And so you look at, from an encryption perspective, now it helps complete our encryption story, right? So obviously before we had data at rest, data in transit. Now with confidential computing, we bring in data at use. This protects against insider threats, data breaches, third-party hackers as well. And so now, when you look at it, essentially think of this as now protecting against in-memory attack surface areas and helps establish trust boundaries. So as you kind of look through, you've got your Kubernetes admins, you've got your Hyper-V admins, you've got your cloud admins, you've got other containers that exist there. All these are problem sets you got to worry about in a typical Kubernetes-based deployment. So now, essentially, with confidential computing, we can actually bring all of those outside of the trust boundary of the application. So essentially, your own AKS cluster admins are now restricted. Your control plane and daemon sets are restricted. Cloud and host operators are restricted. AKS worker node operating system is restricted, and the other pods are restricted from accessing the application as well. And so really, there's a suite of things that we're bringing through. So everybody's probably saw confidential VM, which is essentially, think of that as, you deploy a node on AKS, you've got a node pool with CVM worker nodes on there, and you deploy a pod in there. That pod is that single pod, or I deploy 10 pods on there, they're all part of the trust boundary. What I'm going to talk about in depth as well is number 2, which is essentially around confidential containers on AKS as well, which is essentially enclaving. And I'll bring that around as well. And then obviously there's GA of Intel SGX as well. You can see the different trust boundaries. The key things you look at when you look at this diagram is by default, and the key that we're looking here is the attested, integrated, and isolated trust boundary. So that's the key thing. So you can see, as we look at each of the options that exist, which trust boundaries are being configured. So now as you start to look at your application, you see the requirements of your application. Do I trust the admin? Do I not trust the admin? You can start to see how these offerings kind of line up for your application topology, right? So maybe 5% of my applications go in this topology. Maybe another 5% go in this topology. And you can start to segment out your applications as well to provide that isolation that you need. So for us, I don't know,
Maybe a silly question on the previous slide. So why doesn't, on a CPU level, doesn't Intel support all the things that AMD does?
Great question. So there's different work that's going on from different vendors. Oh yeah, so he was asking about why is there such a fundamental difference between Intel and the AMD side. So each of the vendors are working on 2 different feature sets, right? So obviously the most secure solution that offered right now in the ecosystem is on the Intel side, right? So there's specific SKUs that you can leverage, but you can see that's going to be isolation down to the pod level, right, as an example. Whereas on the AMD side, you're actually going to get the entire topology, right, is going to be segmented off. Obviously, those are evolving, and as we're working with the different vendors, they're working on chipset isolation, chipset capabilities, which will continually evolve this space as well. But this is essentially where we're at. Now, where we're focusing really hard is on the middle as well, providing a full end-to-end solution, fully partnered with open source as well. Make sense? So essentially, the first thing we announced, I announced this at KubeCon Detroit as well, but essentially now we have pod sandboxing on AKS. What is that really about? So really what we did is we integrated open source Kata with AKS as well. So now you can provide strong isolation. If you're familiar with Kata-based capabilities, it's just a nested VM that you're essentially putting on top of your worker node. So I've got a 3-node worker node. I can now build nested SKUs on top. And so if I look at the topology here, so this is a typical AKS cluster, Kubernetes cluster that exists today. The key thing is that without Kata, essentially that kernel is shared. And that's the big thing. So if you look at the attack vector that essentially Kata is going after, it's around that kernel, that compute layer. So in a traditional model, that kernel is all shared. So technically, if I have 10 applications deployed on there, maybe I did all my work to make sure 9 are within, deployed right. But now I've got a vendor or something that comes in and deploys everything completely against my security principles, right? Well, now that introduces an attack vector. So technically, they compromise that one. Now I could use the shared kernel to get to the other 9, as an example. Well, now with Kata, now I can segment that workload out, as an example. So think trusted versus untrusted as an example. But the idea is that on top of that shared kernel, we now build nested VMs on top, right? And so think of now taking applications and isolating them within the nested model. So the idea is with that configuration, if that application does get compromised, it's technically only compromising itself, right? Because it's within its own compute boundary. For us, it was pretty easy. It's seamless integration. All we really did was integrate the Kata runtime. Pretty straightforward, no real magic there. Pretty nice to do. Now, what does that really mean? It's pretty common as we look across. I'm curious in the room how many people have done this. I can't tell you how many customers I've talked to that have say a 3-node Kubernetes cluster with 1 application on there, right? So, because they're worried about, that's, the boundary that exists, right? So, is there an opportunity to get a little bit denser, right? Especially in these cost-cutting days. Is there an opportunity for me to get denser? What does that mean? What does that look like? We're not saying we answer every single multi-tenant based architecture, but depending on what your trust boundary is. Like I said, I trust the admin. I can now I can start to carve out workloads, right, as an example. And instead of deploying a 3-node cluster with 1 application on there, maybe I can deploy 10 as an example, or 20, whatever my model is that makes sense for me. So I can start to stack them in. There's another thing that we're doing. So as you look across other announcements coming down the road as well, this is definitely an area we're diving into even further, because if you think about the operations day 2 constructs, those we don't have good answers for yet. But what we've started to do is do compute level isolation, right? And that's the key thing. So when we look at some of the building blocks for multi-tenancy, this is definitely one of the cogs. All right, so let's see if this demo will work.
This is a demo of Mariner AKS using Kata containers and Cloud Hypervisor to run VM-isolated containers. There are multiple motivations behind this project. VM container isolation will enable us to bring up confidential containers on AKS with minimal infrastructure overhead. Additionally, VM-based container isolation lays the groundwork for supporting multi-tenancy within AKS. This project is being built on top of Microsoft-developed virtualization technology so that we can be the best Azure guest possible. To facilitate these lightweight VMs, we've decided to use a combination of Kata containers and Cloud Hypervisor. Kata was a natural choice for VM management because it's a well-maintained open source project that integrates cleanly with Containerd and is built with extensibility in mind. To run the utility VM, we're using the open source Cloud Hypervisor as our virtual machine monitor. Cloud Hypervisor is a lightweight and modern VMM written in Rust. Microsoft has a strong history of contributing to the upstream, and it's exactly what we need to spin up small VMs within a Linux VM. Let's go over the lifecycle of a container requesting utility VM. To begin with, we see that our K8's pod spec has requested the runtime class name Kata. This info is passed down through the K8's control plane, through kubelet on the Mariner AKS VM, and into container D, which then decides that our containers requested the container D shim Kata v2. Kata then instantiates a new Cloud Hypervisor VM running the Mariner kernel and a super lightweight Mariner root file system. Once the VM is created and Kata agent is running, the container dshim communicates with Kata agent, managing the lifetime of the container and providing a channel into the VM for K8's features like container logging and exec. When the container's lifetime is finished, the Kata shim terminates the VM, cleaning up the container's entire runtime environment. Let's go ahead and watch it in action. Here I have a Mariner AKS cluster with Kata enabled, waiting for work to run. Up top, we're watching for processes named Cloud Hypervisor. Looking at this Ubuntu deployment, we can see that it's selecting Kata, and it's using the latest Ubuntu LTS container image. The exact image doesn't matter, it could just as easily be Mariner or any other container image the customer wants to run. Let's go ahead and schedule it on the cluster. We can see that Kata immediately starts up a VM and starts the container within that VM environment. We then scale the deployment up and we can see that Kata starts a second VM so that this new container runs isolated as well. When we scale the deployment back down, Kata quickly closes down the VM and reclaims those resources. To show that we still have access to normal K8's functionality, we can exec into the container, and we can dump the etcos release. To prove that it's running within the Cloud Hypervisor VM we see listed, we can kill the sandbox VM and observe that we lose our exec session into the container. However, because we're running in Kubernetes, the container is immediately rescheduled, and we can see Kata recovered by booting up a new VM. We're excited to be working on the next generation of container and virtualization technology, and can't wait to show off what comes next.
So a couple of key artifacts there. So notice the runtime class that was kind of mentioned before. So that, if you look at it from an implementation perspective, that's all we're talking about. You specify the runtime class. So when you deploy your application, that's shimming it into that nested VM, right? So right now we have that merged with Mariner. So if everybody's aware of Mariner, our container optimized OS that we have out there as well. So everybody's following probably our story about Ubuntu 18.04, Ubuntu 22.04, and now Mariner. There's some things there around the kernel and stuff like that. So a lot of our development right now is going right into Mariner because obviously we own it from top to bottom. So it's a quicker integration stack. So if we look at this from an implementation perspective, this is obviously predicated on the Mariner OS as a sub.
This is a
let me get out of that. And so now, think of pod sandboxing as a preliminary capability we needed to achieve the end state that we're shooting for is around confidential containers. The open source initiative is called COCO as the acronym, but it's essentially confidential containers. So now if you look at Kata as that segmentation, like I said, the key use case for Kata containers is compute isolation, right? I trust the admin, I've got compute isolation, but I now have normal kubectl functions that exist. But now I bring confidentiality into that, now I change the conversation, right? So essentially looking at bringing transparent and auditable environments, reproducible environment, container and config integrity, immutable post-launch, measure all and attest, smallest possible trusted computing base, data and code shielded, and a hardened environment with lockdown access. And so what does that essentially do? It changes the conversation. So now if you look at the trust boundary, right? So essentially the Kubernetes shared host OS is out of the trust boundary. The Kubernetes runtime kubelet is out of the trust boundary. The hypervisor, out of the trust boundary. The root bootkits in the host OS, out of the trust boundary. Guest VM agents, host operator, AKS cluster admin, Azure tenant admins, all out of the trust boundary. And so how does confidential containers provide protection against threats? Hardware root of trust. Customer viable, verifiable remote attestation. That's the big piece, right? So through Microsoft Azure attestation, now I've got attestation to the state. And then memory encryption, and then runtime data and code confidentiality from Azure Operator and your own operator. So as you look at, essentially, COCO on AKS threat model deployment stamp, right? So you can see here, you've got the Kata shim, you've got the CRI, container D, you've got kubelet, you've got kube proxy as a configuration. Let's see if it goes through. Oh, There we go. Sorry, my deck locked up. Oh, there we go. And then I can see, essentially now as I start to deploy on my AKS worker nodes, now as I start to spin up containers in there, I've got everything segmented out. So you can see the blue blocks, essentially in this model, are outside of the trusted boundary, and essentially the blue arrows are essentially attack surfaces, right? So as I start to segment it out, there we go. Essentially now Coco is starting to build those lines of segmentation, right? So essentially now I'm defining out what my trusted components are. You can see the firewall, the cloud storage. You can see that there's DM encrypt in there, DM verify, the root FS, host file encryption through config maps, secrets, CSI are all integrated in, essentially from a configuration point. Oh. Come on. Oh, there we go. It's building out the point. Sorry about that. And so now the key thing is you look at the attestation for verification. So now, as you can see, obviously with CVM, you get platform code and configs, right? So that's the key thing. And so I can see, hey, look, I've got my AMD Milan Sev SMP, I've got my container guest OS, and the container runtime is all platform and configs are fully attested, right? And now, essentially your code and your config is brought within that trust boundary. And so the other cool part about that is you look, if you remember the pod sandboxing demo where we had the runtime class, you would specify, I've already got my Microsoft hypervisor there as well. And now what I'm saying is I've got an additional runtime class I would specify, which would drop that pod into that pod sandbox as well and bring that attestation boundary into place. So with that being said, we were working hard to try to get this to public preview as well, but we are actively seeking people who want to preview this, go there and sign up, and we will give you access to the code. So that's the key place to start. All right, so lastly, I know I'm good on time as well. The other big thing to look at is obviously around RBAC. So there's a lot of things that we have from an RBAC-based perspective. Simply put, if you look at from a auth-N and auth-Z perspective, authentication and authorization, we have multiple tools that are fully GA'd in the space. So it's recommended, obviously, when you deploy an AKS cluster to AAD and integrate that cluster. Why is that important? Because now I can do JIT access policies, conditional access policies, so I don't have to have kube admins or cluster admins just sitting on the cluster for 2 years, right? I can give them just-in-time access to do what they need to do on the environment, and oh, by the way, it's auditable. And then obviously with RBAC, I have different flavors I can do as well. The native out of the box is Kubernetes RBAC, which is just the native cluster-based topology. We've also GA'd Azure RBAC as well, which is, think of that as now bringing IAM-based policies down across on top of the Kubernetes RBAC policies. So depending on what your requirements are, we have a lot of tools that can help you essentially bring your environment to be compliant. That's the key thing. So by bolting on Defender, by bolting on a monitor, by leveraging Kata and the confidential suite, you can build a highly regulated environment within AKS without compromising a lot of your performance. Thank you very much.